Hi, I'm Grace, and I'll be your lead presenter as I take you through where the development journey of our coffee shop Jukebox app has led us so far. Now, I don't think I have to tell you that music often defines atmosphere. That seems like a pretty obvious truth. The right songs can make any place feel inviting, creative, and unique. Now, the problem is a lot of places, including shops, don't have the time to fine tune their music tastes, so they rely on generic playlists or automated streaming services, which often fall victim to the same traps of repeating tracks or failing to reflect the shop's individual character. This often results in customers growing bored or disengaged with the atmosphere, and employees then face even more stress trying to manage those playlists while fulfilling the rest of their main job duties. And when music is treated as background noise instead of a tool for shaping the brand experience, it's not good for anyone. So we set out to create a system that lets music enhance identity and engagement, rather than just fill the silence. This is perhaps best exemplified in our hypothetical example that involves three prospective perspectives. The first is Brandon. He's a customer who frequents the local coffee shop. But when he goes, he's often frustrated by repetitive, bland, or uninspired playlists. He wants variety and the ability to influence the atmosphere and what plays. He desires an atmosphere that reflects the energy of the customers and their taste. Sophia, a barista at this local coffee shop, is often burdened by the extra responsibility of managing music during those busy shifts. She's stressed out more than she should be trying to please everyone while keeping her workflow efficient. She needs a system that runs smoothly without having to pay constant attention to it. And Daniel, the proprietor of the coffee shop, he values brand consistency, but he fears losing control and thus money if customers pick songs freely. He sees the stale music taste as harming customer satisfaction and reviews, which obviously affects the bottom line. He wants engagement tools that come with strict rule controls to preserve the shop's identity. And that's where we come in. Our system is designed to do these things. Customers can request and vote on songs and view the live queue. The administrators, meaning the owners, can set the rules as to what's allowed and manage or override what's in the queue. The system itself auto-skips songs that reach a downvote threshold, determined by the users. And duplicate or excessive requests get filtered automatically so that nobody has to worry about it. Now, obviously, you want things to be fast. Requests and loads should complete in just a few seconds at the most. The system should be able to support a number of concurrent users so that all the customers in the shop can have a say. It also has to be reliable. It needs to preserve the state of the queue through the restarts and run reliably with minimal downtime. And it needs to be sure that only administrators have access to those authorized tools. And for the administrators, you also want the code base to be modular so that adding new rules isn't difficult. For the user interface, the user should always access via a QR code. No need to install an app, just open the web browser. There should be a search bar with live results that update automatically. There should be an upvote and downvote button to reflect the downvote threshold that we mentioned earlier. You should be able to get instant feedback on those actions, and you should be able to do all of that from your phone. Administrators, for their part, should have a dashboard that handles all of those responsibilities. We spent time to build this with HTML, CSS, and JavaScript, but we decided not to use any frameworks because we wanted to establish a consistent UI design language without those constraints. Obviously, the front end connects to the back end via the REST APIs and real-time socket.io updates, and our front end itself is deployed on Render for fast, lightweight delivery. The back end is primarily powered by Node and Express.js. Socket.io handles the real-time communication between the front end and the back end. Our Postgres database stores users, requests, votes, and the current state of the queue to preserve it through shutdowns. The Spotify API provides our actual playback functions, and obviously our backend is also deployed on Render. Now we'll hear from Samuel and Adriana as they give us a dry run of the system as it is.
Hello, my name is Samuel, and I am going to be presenting our web application's structure and just generally how we have it set up. So here you can see our render deployment page, and we have the front end, the back end, and the database using Postgres. So we have them all successfully deployed. So, and here is our front end opened up. This is the queue view. So you can view all the songs that are currently on the queue. I am using a placeholder image at the moment, but all of this other information, like the song title, the artist title, and the release title, and the votes over here, are coming directly from our database. And you can upvote it, and it marks that you've upvoted it. And also we have our make a request page. So anyway, I will show the structure of the project in our code. So I'll just go through the process of loading the queue, starting from the front end, going all the way to the back end and database, and then coming back to the front end, just showing how it runs through the code. So it starts in the front end on this index.html page that I just showed you. So that has this script, queue.js. So let's go over there and see what's in there. So on the loading of the page, it will load the queue first, and let's look in there. So that will call or fetch the it will fetch the or send a GET request to the backend to get the queue, the full queue with all the queue items. So now we can look in the server.js where it handles that fetch request. So we've got all our routes down here. We can see API queue. So this is where it sends the route to fetch the queue to the queue router. We do have a little middleware function that runs in between that for logging events. This automatically logs any request to the backend. And then after that, it goes to the queue router in API queue. So then for the get queue request, which is just the basic API queue route here, it calls get queue from the controllers, from queue controller. So let's look in our queue controllers. So it will call this function get queue, which essentially sends a request to it calls the queue service, which we imported up here, and it calls get queue on that queue service. So now we can go look in our queue service, and we can look at the get queue function, which proceeds to call the queue models function get all queue items. So now we'll look in the queue model, and here it will get all queue items here. Oops, not that one. Get all queue items here. It creates this query for our database, which gets all of these attribute fields from the queue table and the tracks table, and that will get all the information we need for the front end. And so yeah, now let's look at our actual database structure. So as I said, we need the tracks and the queue tables. So the queue basically just stores the Spotify track ID. That's how it knows what track it's actually referencing. And then that is the information for the actual track itself is stored in the tracks table, which has the Spotify track ID as its primary key. And that has the title, artists, release name, cover art, URL, all that stuff. And then, but for the queue table, for each queue item, it needs to have is now playing, position, upvotes, downvotes, and will be skipped. It needs to have all that information for the front end, so the front end knows how to render that specific queue item. So the queue model will get that information from the database, and then it will return the information and return it to the queue service. So the queue service gets that information, runs some checks on it, combines the user's votes. So if the user who's loading the queue has voted on one of those queue items, then it will mark those votes when it reloads the front end, so it is consistent with what the user has already voted on. So it combines that into the returned result, and then it returns all of this to the queue controller, which takes that result and basically just checks it to make sure everything's there, parses it out, and then returns that information to the front end. And let's go back to our queue.js in the front end. So once we finally got all that information back from the back end. So now this queue.js will sort of format this response, and it calls render queue item down here, which just calls a bunch of functions that are down here. The main one is build base queue item, which it puts in this image, which I'm using a placeholder right now, but it'll eventually use the actual one from the database. Then it gets the title and the artists. It accounts for multiple artists returned, and the release name and the amount of upvotes and the downvotes. And also another function that will be called is apply skip style, which if the queue item is downvoted enough that it will be skipped, then it will gray out the queue item. As you can see here, this one right here is sort of grayed out, so that means it's going to be skipped because it has, unless it gets more upvotes or less downvotes. We've also got apply, hide user request vote buttons. We've got all these things that just sort of make sure the rendering of the queue is accurate. And yeah, so that's pretty much how this view queue process works, from the front end to the back end to the database and all the way back. Thank you.
This is Adriana Garcia, and I'm demonstrating the user-facing search and request functionality for the Coffee Shop Jukebox application. My work focuses on the live search interface and instant feedback system for the song request. On this page, users can browse and search through available songs. The interface displays song title, artist, album, and artwork, making it simple for customers to preview music before adding it to the queue. I'll begin by demonstrating our search feature. Users can type in any part of a title, artist, or album to filter results in real time. As I type, the list updates instantly. No page reload required. This satisfies Rec UI 2, which requires a responsive live search interface with song, metadata, and cover art displayed. After clicking the button, changes to requested with a check mark, and a confirmation toast appears. This fulfills Rec UI 5, which states that users must receive immediate visual feedback after interacting with the system. This improves usability by clearly showing the user that their request was submitted. The interface was also designed with performance and accessibility in mind, ensuring fast response times and usability on different screen sizes. These align with my assigned non-functional requirements, including quick loading times and responsive UI behavior.
Now we'll hear from Jonah, who's helpfully written some tests to determine whether our system is working correctly.
Hi, my name is Jonah. For demo 1, I made the backend demo ready. I did a health check, a database check, and a song queue you can add to, vote on, and delete. Start the server. You run that command. Should be running on port 3001. Let's look at our health check. Refresh. Should say true and should give the time. Let's do our database check. We also refresh. It's not connected yet. That's okay. We don't have a database set up yet. In the CRQ, we have this. Right now we have Blinding Lights by The Weeknd, as requested by Jonah.
This hasn't been a project without significant difficulties. We've had trouble coordinating schedules and progress among a small student team, just 4 of us, balancing coursework and outside commitments. We've had to put together a minimum viable product in roughly 10 weeks, while also meeting detailed documentation and reporting milestones. I've had to manage parallel development across front-end, back-end, and database layers, and above all ensure consistent communication between those individual components. As for what's left, we still need to integrate fully with the Spotify Web API for playback. We need to complete our controller model implementation so that all of our functions can handle each other. We need to add the last few interface pages for handling admin reports and displaying the customer-facing rules. And finally, we need to conduct a full-scale local test to make sure that all of our components work seamlessly together. With that, I'd like to say thank you for watching, and I hope you'll stick with us as we move into the next stage of working on this project.